Shooting a basketball is an example of projectile motion. Projectile motion can be defined as motion in the x and y direction.
In order to start talking about the concepts of projectile motion, we must assume that air resistance and the rotation of the Earth are negligible. This means that an object's path while in projectile motion is parabolic, because gravity is the only force acting upon it.
During projectile motion, the x and y directions are completely independent. This means that we can split projectile motion into x and y components. For example, the initial velocity in the x direction can be found by multiplying the total initial velocity by the cosine of the angle the object is launched at. The initial velocity of y is similar, except sine is used instead of cosine.
Velocity in the x direction is always constant because the acceleration in the x direction is 0. However, in the y direction, acceleration is always 9.8 meters per second downwards. This means that when an object is going up towards its peak, its velocity is decreasing, while it is on the way down from its peak, its velocity is increasing. These are the graphs for velocity versus time and acceleration versus time.
Finally, all the kinematic equations from independent x and y motion apply to projectile motion.
Range is defined as the distance along the horizontal plane it would travel before reaching the same vertical position as it started from. At any constant given velocity, the firing angle 45 degrees will result in the longest range. Also, angles that are complementary will result in the same range if the object is launched at the same speed. In this case, the object shot at the larger angle will stay in the air longer.
For example, on a two-dimensional plane, if two balls are shot at 70 meters per second, one at 30 degrees and one at 60 degrees, they should land in the same spot. However, the one shot at 60 degrees will be in the air longer.
These are all the key concepts of projectile motion.